So good day everyone, I am Banshini Ubas and today we're going to discuss an organic compound which is alcohol on how to name and structure it. So an alcohol is an organic compound in which a hydroxyl group is covalently bonded to a saturated carbon atom. Now let's proceed to the rules for naming alcohol that contain a single hydroxyl group. So let's have an example. CH3, CH2, CH, CH2, and CH3. And the substituent CH3 or the methyl and OH dialcohol or the hydroxyl group. Now first step is to locate the longest chain that contains the hydroxyl group. So step 2 is to number the carbon chain. Now we will count it from left to right since the hydroxyl group is located in carbon 3. And the given rule is to position the hydroxyl group at the smallest carbon atom. 1, 2, 3, 4, 5, 6. So 6 carbon. And 6 carbon means hex or hexane since it is a single bond, and since it is a alcohol we will cancel E and exchange it to OL to become hexanol. Next step is to name and locate any other substituent present. So we have methyl at carbon 3, 1, 2, 3, then we was for 3 methyl, so the location of hydroxyl group is in carbon 3, so we must put so we have 3 hexanol. So well, all in all we have 3 methyl, 3 hexanol. Now let's proceed to the naming more than one hydroxyl.
Hello everyone, my name is Marian Jules Zapanta and I will be discussing about the IUPAC nomenclature for alcohols with more than one hydroxyl group.
So for the nomenclature for alcohols with more than one hydroxyl, we have to follow some steps, which is step 1, locate the longest continuous chain that contains the hydroxyl group. If there is more than one hydroxyl group, all of them must be on the parent chain. Step 2. Number the carbon atom so that the hydroxyl group receives the smallest number possible on the parent chain and identify the position of the hydroxyl. Step 3. Name and locate any other substituents. Step 4. Place the multiple bond position number immediately after the number of carbons in the parent chain and before the suffix OL or all. If there is more than one hydroxyl group, add the suffix modified to indicate the number of hydroxyl groups.
So we have an example here. So step 1 is to find the longest chain or the parent chain. So we have 1, 2, 3, 4, 5, and 6. 6 means hexane or 6 carbon is named hexane. Step 2 is to number the carbon in the longest chain. So we have 1 here, 2, 3, 4, 5, and 6. So why did we start here? It is because this carbon is connected to a hydroxyl group. And when it is nearest to a hydroxyl group, in that area we have to start the counting. So we have 1, 2, 3, 4, 5, and 6. Next is to locate any substituent. We have a hydroxyl group in carbon 1 and a hydroxyl group in carbon 3. So we wrote 1, 3 hydroxyl. It means that there are a hydroxyl group in carbon 1 and carbon 3. Next is to start naming it. First, we have to put the numbers. So 1, 3. Next is dash hexane. Since we have 2 hydroxyl group, we put di, and this is an alcohol. Suffix will end in OL. So the name for this structure is 1,3-hexane diol. So we have another example here. The step 1 is to find the longest chain, which is 1, 2, and 3. 3 carbons means propane. Next, we have to find the substituent. The substituents here are all the hydroxyl group, and either one, we will start with numbers 1, 2, 3. And if you start counting here, it's all the same with 1, 2, and 3. So just start from right to left. Okay, since we have 3 hydroxyl groups in the carbon 1, 2, and 3, we will write 1, 2, and 3. These are all hydroxyl groups. So in naming this, we will first put the numbers. We have 1, 2, 3 dash propane. And since there are 3 hydroxyl groups, we will put tri and the suffix OL since this is alcohol. So the name of this structure is 1,2,3 propane triol. And in this chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest chain we have is 9. And 9 is no name. Next, we have to number the carbons. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. After numbering the carbon chain, we have to locate the substituents. So we have 2 and 4 for the hydroxyl group, and at carbon 6 and 7 we have the methyl group. So in naming this, we have to put first the methyl, and since there are 2 methyls, we have to put 6, 7 dimethyl, since there are 2 methyls in the structure, and the 2, 4 hydroxyl group, and then the parent chain no name. And since we have 2 hydroxyl group, we have to put di and the suffix ol. So the name of this structure is 6,7 dimethyl 2,4 diol.
Since we are done with the nomenclature for alcohol with more than one hydroxyl group, I will pass you on to Miss Mariella to discuss about the structural formula, which are the condensed and the expanded structural formula.
Good day, everyone. I'm Mariela Fatima Ricania, and I'm the next one to discuss the condensed and expanded structural formula. So what about the condensed structural formula of this one? So the first step is we need to count the longest carbon chain. But for this example, we need to start to count here because we need to remember that our priority is alcohol. So we need to count the nearest alcohol group, alcohol or hydroxyl group. So it is located here. So we need to count it from right to left. So 1, 2, 3, 4, 5. So since it has a 5 carbons, so we name it pentane or 2-pentane. But we have a alcohol, right? So we need to change it and name it 2-pentanol to emphasize the alcohol. So the answer is 2-pentanol. This is the final answer. The next example is the 2-methylhexanol. So first we're going to write the 6 carbons. So 1, 2, 3, 4, 5, 6. Then it has a substituent located in the second carbon. So here, CH3. And then the alcohol, which is located in the first carbon. So OH. So here, then. So this one. So for now, let's have a expanded structural formula. So what about this expanded structural formula? How do we name it? So the first step is to name the longest carbon chain in which the nearest hydroxyl group is attached. So we start to name from right to left since the alcohol is located here. So 1, 2, 3, 4. So since it has 4 carbons, so we name it butane. 2-butane since the alcohol is located in the second carbon. And change the E. We need to drop the final E rather, so this is named as 2-butanol. So this is the answer. So what about this example? How do we write in expanded structural formula? So the first step is we need to write the carbons. So from the suffix hex, so it means it has 6 carbons. So 1, 2, 3, 4, 5, 6. And then the location for the alcohol is located in 3, 4. So 1, 2, 3, 4. And the ethyl group and the rest we need to write the hydrogens. So this is the expanded structural formula of 2-ethyl and 3,4-hexadiol. So hexadiol denotes 2 alcohol. So this is the expanded structural formula of it.
Hi guys, this is Jel Siloria and today I'm going to teach you how to draw an IUPAC naming in alcohol using the line angle.
So now we're going to draw a line angle structure of IUPAC naming on alcohol. So first step in drawing a line angle. Begin with the carbon backbone or draw a zigzag line to present the carbon. So we're here now to draw a line angle structure. Begin with the draw of zigzag line to present the carbon chain. Since we are having a pentanol which is 5, so we have 1, 2, 3, 4, and 5. Now, identify the location of the hydroxyl. 3. Place the OH group or put the OH group on one of the carbon atom in a chain. So we have 3-methyl, 2-pentanol. So add hydrogen atom to simplify the structure. You omit hydrogen atom bonded to the carbon and just present the carbon atoms with a line segment. So we are going to put the OH here. Oh, going to erase. It's too long. OH. So now we're going to find the 3-methyl. Since 3, we're going to locate where is 3.
So that is how you name and create a structural formula for the organic compound family alcohol. We hope that you learned something from this video. Thank you for listening everyone and have a nice day.